One way we describe how we test software relates to the sources of knowledge we use to derive tests. The most common classifications are functional testing and structural or structure-based testing. There are several near-synonyms for both of these types of testing. For functional, there are black box, feature-driven and specification-based testing, for example. For structural, there are glass box, white box and code-based testing. I say near-synonyms because these alternative terms derive from slightly nuanced variations from the classic functional and structural test perspectives. But what are these two perspectives? Why are there variations? These terms date from the 1960s and 70s. Is the distinction meaningful nowadays? A functional requirement sets out what the system should do for you. We could call this the specified behaviour. The requirements might be captured in a specification document. The requirements are usually assigned to separately defined features or functions to describe what each is responsible for doing. Functional testing, therefore, treats the system as a black box. No knowledge of the internals of the system are required or assumed. We are not influenced by how the system is built in this case. Tests are derived from a specification of required behaviour which is external to the system itself. The external specification of requirements is used to select or design tests. The specification is also used as the baseline or oracle for test results. Functional tests can be used at any stage: component, integration, system or acceptance testing. Developers will run functional tests on components and subsystems if behaviour at these levels is specified. But usually, most functional testing takes place in system testing and user acceptance. These tests do not require technical knowledge of the code or its structure. We don't need to see the system code, so functional testing is often called black box testing. Now, structural testing, also known as glass box or white box, is based on the internal structure of software. The software code itself and its structure is used to design test cases. Obviously, the code must be visible and understood by the tester. Structural testing is the main concern of the developers of software. So you need the skills of coding in a particular programming language to structurally test a program written in that language. Of course, the expected results of any test still need to be derived from the requirements. So we have this split of structural testing performed usually by developers and functional testing mostly performed by testers and users. At component and subsystem level, developers do mostly structural testing with some functional testing. At system and acceptance level, we do almost entirely functional testing. In most projects, the trend from component testing to system and acceptance testing, from small to large, is mostly structural to almost entirely functional testing. That's the trend, but both perspectives, structural and functional, can be useful at most stages of testing. There are variations of structural testing that don't require code knowledge. The structure used might not be the flow of controlling code, but rather a menu hierarchy or the architecture and messages that are passed around a system. The concept of structural testing can be applied to any kind of model, technically or business-oriented, but especially models based on directed graphs, a bit like flowcharts and so on. You'd be right in suggesting a lot of system and acceptance testing follows paths through a business process, a flowchart in effect. That's right, but I would say the system and acceptance tests follow the structure of the business process. Component tests follow the structure of the component code. System-level tests are created without reference to the implementation. They are independent of the programmers. Component testing is often performed by the developers of the component, and developers might take the assumptions they had while writing code into their testing. Both test types are valuable. Developers can test all of the obscure parts of their code. System-level testers bring independence to the job of testing, so aren't influenced by the implementation. Now, there are some variations of functional testing. One type is called specification-based testing, where a specification is used directly to derive tests and expected results. But black box testing could involve testing without a specification at all. The tester's knowledge and mental models could be the source of test ideas, and expected results might be checked for consistency of behaviour rather than rote checking against requirements, for example. Just to confuse matters, there's also a flavour of testing using a hybrid approach called grey box testing. Grey box testing is testing with partial knowledge of a system's internal structure or workings. You might not have full access to the source code, but if you know enough about system architecture, algorithms, APIs or data flows, you can probably design more informed and effective tests. Is the functional structural paradigm still useful? Historically, I think it derives from the days when developers did most of the testing. Early structural tests were driven by the need to cover code, and this testing dominated the testing effort many years ago. Of course, functional tests are driven by the need to cover requirements too. The split of developer testing and system and user testing can be blurred nowadays, and responsibility is not a good indication of what tests are actually run. The significance of functional and structural is that it defines a test approach based on different sources of knowledge, the code and the requirements, however presented to the tester. But even this separation isn't perfect. There are structures, models, external to the code that can be used to derive tests. The real issue is this: we must normally utilise multiple perspectives to test a system thoroughly. The phrase diverse half measures sums up this approach nicely. Neither functional nor structural tests alone are sufficient. They are both half measures. We always need a blend of both structural and functional tests to gain confidence that software works. Now, there is no defined right proportion for each approach. Structural testing should be sufficient to give developers confidence their code has been tested in isolation and can be integrated with other components to build a complete system. Functional testing should be sufficient to give users confidence the integrated system has all required features working to support their business goals. If you want to know more about the concepts I'm talking about in the Glossary of Terms videos, it will probably help you if you take a look at the Leadership in Tests online class that I created a year or two ago. It covers some of the topics in more detail and obviously provides more of a structured approach to explanations of the concepts, and also gives you some idea of how to do some of the things that I talk about. I hope you can take a look at it and get value out of it. The link is below, bit.ly/leadintest.